Hello everyone, welcome to our 6G-TC project. This project defined in 6G-BRICKS OpenCall1 project and based on ns-ORAN testbed. First of all, I want to describe the NS3 and ns-ORAN. NS3 is the open source simulator for the network and it can simulate all the sides of the network. For example, core side and the RAN side. Also can simulate the behavior of all the components. Uh, in this testbed, we have open software community, RAN intelligent controller. Also NS3 simulator for simulating our networks. Also, we have mmWeb module for simulating 5G related components and behaviors like G-Node B and some other helpers for like ML helper for simulating some behavior of the network. Also, we have E2 termination, also called E2C, responsible for transmitting the actions of the RIC to the RAN and the KPI of the RAN to the RIC over the E2AP protocol. We are used from this testbed for collecting some dataset for training our ML models. In this case, we are used to train, collect the data to train the anomalous behavior detector model. And finally, we are recommended some action to the RAN for be actionable. Uh, We are used from this testbed for collecting multiple datasets. For example, in part of the number of UEs, changing the number of UEs, or the low bandwidth or high bandwidth simulations and low density or high density UEs in the area. As you can see, we are divided our UEs to three parts and allocated different UE traffic pattern for each group for designing the SLA of the each slice in part of delay and throughput or bit rate and bit error rate and others. Uh, so can describe our end-to-end testbed. This is our end-to-end testbed and includes multiple parts. First one is NS3 pod that's responsible for simulating the end-to-end of our network, like core side that simply use serving gateway, PDN gateway, and mobility entity module. Also, we have Python SymWatcher and Telegraph pod. These two responsible for reading the output of our scenario. That's in format of some text files for transmitting them, transferring them to the InfluxDB database for structured data. So we have two ML models. First one is traffic classifier, and three others is anomaly detector xApps. First one, traffic classifier is based on the hierarchical ML model, and three others is variational autoencoder ML models. Traffic classifier reads the output of reads the KPI from the InfluxDB pod, InfluxDB database, and based on the KPI of the each UE and traffic pattern of each UE, divides them to three vectors and three groups based on their traffic pattern. So send the output to the TSX app in format of anomalies.log file. The anomalies.log file is a log file for writing the output of the traffic classifier. TS6 app reads the output of traffic classifier and detect that if the UE is not in the correct slice on the correct cell, try to hands off the UE to the correct cell, because we are considered that default each cell can support only one slice. I mean that we have only one slice per cell. So other three models read also the dataset from the InfluxDB and out of the traffic classifier, and try to produce some alarms after the handover of the UEs to the correct slice if they are still anomaly. Our RCX app works with gRPC API and send the recommendation to the ns-ORAN pod and say that you should hand off some UEs. This is our workflow that I described in the previous slide. I said that if we have a mismatching of the UE, it means if we have some UEs that has, for example, URLC traffic pattern, but exists in the cell that related to EMBB serving cell, we should hand off the UEs to the correct slice and the correct cell. This handover algorithm triggered by traffic classifier and the anomalies.log file and done with traffic steering app. The next part is testing our scenario, but I want to test it online. First of all, I want to check the database to be empty for correct simulation. As you can see, we have 4 buckets for the data. The last one is related to UE related some configuration and data. The three others related to central unit control plane, central unit user plane, and distributed unit related data. We have used all of the data to the training over the machine learning algorithms for predicting some results and some actions. So we should drop all data from the database for correct simulation. So before running our simulation, I want to show uh, show our cluster, Kubernetes cluster that we are deployed all of our application and pods in the cluster. This cluster includes Grafana for visualizing some results, InfluxDB for storing the KPI, ns3 for simulating the network, and the Telegraph and the Python sim watcher that is inside the ns3, responsible for transferring the data to the InfluxDB. And we have some other parts for the related to OSC or RIC. For example, E2 term and E2 manager related to responsible for transmitting the E2 messages and modulate them and send them to the RAM. In next part, we should run the Python sim watcher for be ready to transferring the data. Now the sim watcher is running and is ready for transfer the generated data from the RAN to the Influx DB. Next terminal, uh, I want to run the our scenario. Maybe the IP is changed. Yes. Uh, the IP is 128 that's related to term part in the RIC. We should change it. As you can see, the all setup response successes exist in there, and it means that we are connected correctly to the RAC. Next terminal, I want to run this integrated app. Integrated app, I mean that we are integrated the traffic classifier and three other anomaly detector app in one Python file. After going to the ns report, we should change the directory to abdts, and after that we can run it. So now the AD and traffic classifier is running, and try to read the data from the Influx DB and produce some prediction in the anomalies.log and some alarms that this behavior is normal or abnormal. We have some delays for running it. So in this part also we should go to abdts folder and run the ts app for handoff the UIs. As you can see, after reading the anomalies.log file, you can see the output in this terminal. After reading the anomalies.log file, it tried to hand off some UIs to another sets and send the success response for us that the handover is done. For see the anomalies.log, you can cat. As you can see, the alarms are in this format. It says that the UI, for example, 17 is abnormal and has mismatch and is not in the correct cell or correct slice, and it should be handed over to the another cell or another slice. And matching slice is also predicted in this part. So you can see all the results that we saw in the terminal. The simulation is finished, and I I hope that this be helpful for you, and thank you for watching this video. Good luck.